This is Learning Assessment Problem 10-2. The problem-solving strategy here is that of magnetically coupled circuits. In the circuit shown, we have two loop currents indicated I1 and I2 that we are to solve for, and we're also asked to determine the voltage V sub O appearing across this capacitor. We note that the two currents I1 and I2 enter the dotted terminals of the inductors, and thus the mutual inductance term coupling those two circuits will be positive. We'll label the self-induced voltage polarities around the circuit due to the self-current circulating in that loop. And then on the exterior of the circuit, we'll label the induced mutual coupling terms, being positive at the dotted terminal with respect to the undotted terminal in each case. So we'll begin by writing the necessary loop equations to solve for the currents, and then we'll use the current I2 to determine that voltage V sub O eventually. We'll do a KVL at the loop I1. So here we have the 4 ohms and J4 ohms, the impedances on the I1 loop, the 24 volt source in that loop, and then the J1 ohm times I2 is the effect of the mutual inductance coupling a voltage appearing across the inductor in the I1 loop. Rearranging this equation, we have now we can do a similar KVL around the loop I2. Here we have again the mutual inductance term plus J1 ohms times the current I1, and this is the voltage induced across the inductor in the I2 loop. So we can write this in a matrix format. So this matrix equation is equivalent to an impedance matrix times a current matrix is equal to the voltage matrix. Note that this minus 24 at an angle of 0 degrees volts is equivalent to 24 at an angle of 180 degrees volts. We'll solve for the two currents I1 and I2 using Kramer's method. The determinant of the impedance matrix is equal to, which is minus 7 plus J24, or delta is equal to 25 at an angle of 106.26 degrees. Now we can solve for I1 equals, which is, or I1 is equal to 4.295 at an angle of 137.18 degrees amperes. Now we can use Kramer's method again to solve for the current I2, which is equal to, or the value of I2 in polar form is equal to 0.96 at an angle of minus 16.26 degrees amperes. Now using the value of the current I2, we can solve for that voltage V sub O at the output side of the circuit. The voltage V sub O equals the impedance of that capacitor minus J4 ohms times the loop current I2. And the polar form of the output voltage V sub O is equal to 3.84 at an angle of minus 106.26 degrees volts.